Welcome to Rethinking Mathematics. This video highlights key points of Chapter 13, 18, and 22 for your viewing and listening pleasure. Thanks and enjoy. Chapter 13, Understanding Large Numbers by Bob Peterson. This chapter highlights how elementary-aged students struggle grappling with large numbers even when they are taught about place values. In order to help facilitate students' understanding of large numbers, Mr. Peterson, the author of the chapter, designed a creative lesson that streamlined learning about large numbers for his students. The night before the start of the lesson, students were instructed to ask their parents/guardians what 1 million and 1 billion meant, and the next day they shared their responses with the class, and subsequently students engaged in activities in which they had to figure out how many days equals 1 million seconds, and they engaged in the same activity with 1 billion as well. Once students developed some understanding of very large numbers, Mr. Peterson wrote 80 billion and 10 million on the chalkboard and asked the students to read it, and then inquired about their significance in terms of the difference in quantity. He explained to the student that the 80 billion is the cost of the war of Iraq for a year, while the 10 million is the cost of renovating their 100-year-old school building and modernizing it. To put the large number in perspective and help the students understand the significance, students discussed graphs from United for a Fair Economy that juxtaposes United States military budget and spending with that of federal social spending. Students found and also learned that the cost of one stealth bomber, which is 2.1 billion, could have paid the salaries with full benefits of 38,000 teachers. These figures were relevant for the student as the principal in their school had announced budget cuts that would result in some teachers and staff losing their jobs. Students were then required to reflect on their newfound understanding of large numbers in their math journals, as well as the disparity of the allocation of funds from the government, in which one student wrote, "This really isn't fair. So much money is being spent when our schools need so little." Chapter 18, What's a Good School? Using Data to Define Measures of a School's Success by Michelle Allman and Almanzia Opeyo. In this chapter, students from an alternative high school who were identified as possessing 6th grade math level skills embarked on a 3-week lesson that was designed by their teacher and her colleague to help the students develop the use of variables to create complex, meaningful expressions, as well as using real-world context to foster the development of proportional reasoning skills. The goal was to help the students develop their overall algebraic thinking. In their 3-week journey to develop their math skills, students were expected to use those skills to critically analyze and investigate equity in the education system. Students were first instructed to brainstorm 5 ways they could measure the success of a school. Some of the 5 ways that they identified included good teachers, better school meal, fair principals, fun classrooms, extracurricular activities, and no drama. The responses of the students was a bit surprising for the teacher, as she noted that even though the students came from racially, ethnically, and socioeconomically diverse backgrounds, they lacked to recognize issues of equity and also struggled with how to describe measurable attributes of a successful school. The teacher and her colleague felt that it was imperative to address those 2 glaring problems in order to help improve their ability to use math to interpret the world and help them to recognize and discuss issues of injustice that may not be acknowledged in a classroom. With the guidance of the teacher, students begin learning to use variables and expressions to represent the world with things they were familiar with, such as number of adults, books, children, etc. Students then worked in groups to figure out average values for the variables and then use those values to create numerical and variable expressions. Once students developed comfort level with their new skills, they needed to apply that skill with variables and expressions to their original lists to measure school success, such as good teachers and/or fair principals, and therefore they were able to create a more measurable attributes. The students then received support from the teacher and her colleague to facilitate the development of proportional reasoning. Part of that entailed investigating state and national data about discipline for different demographic groups. According to the teacher, the data the students were grappling with regarding the apparent inequity they were witnessing and expressing in conversations was highlighted as they investigated the data on detention, suspension, and expulsion for the different racial and ethnic groups. One of the things the students discovered included information about how African American students received harsher levels of punishment for less serious behavior than other students. At the end of their 3-week project, the teacher noted that the students showed they had gained a solid understanding of how to use variables, create and interpret expressions, and reason proportionally in a short amount of time and become more critical thinkers about the education system and our society at large. Chapter 22, The Geometry of Inequality by Andrew Brantlinger. This article highlights the experience of the author when he taught a summer class to a group of racially diverse students who were classified as being low income. This group of students who were enrolled in his class was required to take his course because they had failed geometry previously, and a vast majority of the students were not on track to graduate on time, as mastering mathematics was a major hurdle to overcome. The teacher conducted an interview with his students in one of their learning sessions to gauge views of mathematics. Many of the students interviewed revealed that they felt mathematics was irrelevant in their lives outside the classroom. And so the teacher designed a lesson that would connect geometry to issues of fairness to help students understand how math could be relevant in their lives. The teacher began the lesson by asking his students if they knew who or heard of Rodney King and the ensuing riots in South Central Los Angeles in 1992. Some students claimed they knew, while others were unfamiliar with the Rodney King case. Students were then instructed to get into groups and come up with what they felt to be average ratios of people to movie theaters, liquor stores, and community centers. The students were then asked to use their estimates to make predictions about the number of movie theaters, community centers, and liquor stores in a 3-mile radius in South Central Circa. Although estimating did not involve a great deal of mathematical thinking, the goal was for students to engage with geometric issues that the problem presented. To help jumpstart students' thinking of geometric issues, each group was given a map of Chicago and were asked to draw a circular region with a 3-mile radius. The students were then asked to figure out how many square miles and square city blocks would be in such a region. Figuring out the number of city blocks in circular region within a 3 miles radius generated a healthy discussion amongst the students, as some students were used to thinking about linear blocks as a measure of distance as opposed to thinking about square blocks as a measure of area. The teacher then provided the students with data from Evanston, a mixed-income suburb that borders Chicago to the north. The data showed an area of 805 square miles with about 75,000 people, 8 community centers, 3 movie theaters, and 7 liquor stores. The students figured out that 3 Evanston would fit into South Central, and based on the data from Evanston, they assumed that South Central would have 10 movie theaters, 26 community centers, and 27 liquor stores, especially since the data from Evanston said that it was a typical community. When the teacher finally shared with the student the amount of liquor store in South Central, which was 640, the students were utterly surprised, as they would have never thought that there would be such a significant number of liquor stores. The teacher felt that this was a powerful activity to not only teach about geometric issues, but also helping students grapple with issues in society from a mathematical lens, as the students noted that they were learning about real facts. The end.